Breadth first search algorithm. Principle and example. Breadth first search is an algorithm for traversing or searching a graph or a tree. It explores the neighbor nodes first, then the next level neighbors. On this animation, you can see the exploration order of the nodes. Implementation. Here we have a graph that we want to traverse using a breadth first search. Remember that, unlike trees, graphs may contain cycles, so we may come to the same node again. You can tell this is a graph because two nodes link to F. And here we have the code. On the left side, we see a Python implementation of the breadth first search algorithm. On the right side, the JavaScript implementation of breadth first search algorithm. So we have two parts. On the upper part, we simply initialize a graph using an adjacency list. We also initialize an empty array called visited. This is where we will push our visited nodes in order to avoid processing a node more than once when using a graph. And also an empty queue array. This is where we push unvisited edges of visited nodes. On the bottom half, we have our breadth first search. It takes in a node, a graph, and the visited list. And this version will print the nodes it visits. Note that you could tweak parts of this algorithm to best fit your objectives, but they all have the same principles. So here the first thing we do is append our queue and visited arrays with our input node, since it acts as our root. Now that we have a queue, and while we do, we pop the first node of that queue and print it in this case. Then for each undiscovered edge that the node has, we append the edges to the visited and the queue arrays. And this while loop repeats while we have items in the queue. Because all the nodes and vertices are visited, the time complexity for breadth first search algorithm on a graph is a big O of vertices plus the edges. And that's it. Thank you for watching and see you in the next one.